All right, so we're looking at scatter plots today and graphing them in our calculator and graphing lines of best fit using our calculator. So we call those regression lines or curves because we can basically try to do a regression that is quadratic or cubic or exponential. And so next year in 30-1, we'll look more at those, maybe a sinusoidal regression. But you do need to, although you probably won't do a regression on the diploma exam in math, regular math 30-1, you might be asked on IB exams, okay? If you were to take 30-2 math, you would need to do regressions. So remember, IB is kind of covering a lot of Alberta education, both grade levels, or both academic levels. So scatterplots are widely used to present measurements of two related variables. It is particularly useful when the variables of the y-axis are thought to be dependent on the values of the variable of the x-axis, usually an independent variable. Often that's the case. Below is a scatter plot that relates the percentage of car ownership to the household income for the people of any town. Okay, so that's kind of saying that you can see that it's not forming a straight line, but as income increases, the percent of car ownership increases, right? And it kind of makes sense. You need money to have a car. So the more money you make, maybe the greater percentage of ownership of cars. So on a scatter plot, each point represents a pair of values. The scatter plot shows that 55% of the households with $30,000 income own a car, right? So that's showing this particular point here. Okay, the data plots are plotted but not joined. So the pattern of the data points on the scatter plot reveals the type and strength of the relationship between the two variables. Scatter plots can illustrate various patterns such as data correlation, positive or direct relationships between variables, negative or inverse relationships. Is the slope positive or is it negative? Scattered data plots, nonlinear patterns, maybe it follows a quadratic or a cubic, or an exponential or a sinusoidal, whatever. The spread of data, is it all spread out? Can you even see a pattern? And outliers. Is there one value that is totally different from the rest? And we kind of talked a little bit about that with our box and whisker plots. So, taking a look, we're basically looking at a bunch of different properties here. There's some links that you can look at from StatsCan if you want, but we're not going to go through that because I'm just going to talk to these values. So when the data points form a straight line on the graph, the linear relationship between the variables is strong and the correlation is high. Okay, so we say that it has a strong or high correlation because the points are very, very close to a straight line. They're not perfect. If I were to graph this, say draw a line, a lot of them go through it, but there's still some that don't quite go through, right? This one, and this one, and some are a little bit off there, but it's a very strong correlation. Okay. Then, if we take a look at this one, this one. If the points cluster around a line that runs from the lower left to the upper right, so the last one did as well, but it was a strong relationship, so it was really easy to see. In this case, without that line drawn, a little bit harder, but for sure, as the variable 1 is getting bigger, variable 2 is getting bigger. So if it's going from lower left to upper right, then the relationship between the two variables is positive or direct, okay? And so a positive relationship or a direct relationship means the slope is positive. Makes sense. So an increase in the value of x is more likely associated with an increase in the value of y. The closer the points are to the line, the stronger the correlation or the relationship. Okay? So that's a positive or direct relationship. It's not that strong. It's okay, but it's certainly not as strong as the last one we looked at. Negative or inverse relationships. I tend to call it negative rather than inverse because sometimes when we think about inverse, we think about inverse of a function when you interchange x and y, and that's not really what this is, right? So I think inverse comes more from the more non-mathematical terminology. Negative for sure, right? Because the slope is negative. So if the points tend to cluster around a line that runs from the upper left to lower right, then the relationship between the two variables is negative or inverse. Again, not a super strong relationship there, but definitely pretty easy to see that it's a negative relationship. Slope is negative. Okay, this one, who knows what the relationship is? So that's a scatter plot. All of these have been called a scatter plot, but this one's definitely all over the place, right? So if they're randomly scattered with no pattern to them, then there's no relationship between the two variables. So there's a low or zero correlation. Yeah, so it's pretty hard to tell. Maybe you could do like a horizontal line, but then maybe you could do an oblique or a vertical or whatever, right? So really hard to tell. So it's a low correlation, maybe even zero correlation. Nonlinear patterns. So very low or zero correlation may result from a nonlinear relationship between two variables. If the relationship is, in fact, nonlinear, so points clustering around a curve rather than a straight line, the correlation coefficient will not be a good measure of the strength of the relationship. Okay? So we'll talk more about the correlation coefficient a little bit later. So this is, they're really meaning here this value. And so looking at that, you could, I would not say it's zero, I'd say it's very low. Because it does look like it, as you're increasing variable 1, variable 2 is increasing. Okay, so you could draw a line. It would definitely not be a good relationship, right? Like it's a very low correlation. But what it might be closer to is something like this, okay, a curve like that. So a cubic of some kind. And so that's, as we learn how to use our calculator, you can actually check for different types of regressions. It doesn't have to be linear. Okay, and as I said, you'll learn more about those next year too. Okay, so spread of data. The first one is all over the place. So a scatter plot will also illustrate if the data is widely spread or if they are concentrated within a smaller area. So the first one, widely spread all over the place. Okay, concentrated in the next one, but still, what's the pattern? Who knows? Maybe it's impossible in this case to have a value of x that's between 0 and 3 and 10 greater. So you wouldn't even have a line going that far. We don't know enough about it. Okay, but that's concentrated. This one's spread out. Well, this is kind of logical. Outliers. Besides portraying a nonlinear relationship between the two variables, a scatter plot can also show whether or not there exists any outliers. Well, you don't need any calculations to determine that. Take a look at it. It's this point here is so far above the rest, right? These are all under 10. This is at 50. So that's an outlier for sure. You did the calculations. So when you're drawing the line of best fit, you'd want to exclude that and try to draw a line through these points. But your calculator, when it does a line of best fit, will do it through all points. So it's smart, but not super smart. Okay, so now we're going to do some work. It says the math teachers at Henry Wisewood are interested to know if there is a correlation between students' mark in 10C and their mark in 20-1. Following data is a random sampling of 33 students. Okay, so 10C mark, 20-1 mark. We can use the TI-83 calculator to draw the scatter plot, determine the equation of the line of best fit, and calculate the correlation coefficient R. What is that? Well, the correlation coefficient will indicate the strength of the relationship between the two variables, and we can use the line of best fit to make predictions. So first we need to turn the diagnostics on. So as part of your calculator, you kind of have to get it ready to do this kind of stuff. Okay, so when we do a line of best fit, our calculator will give us the equation for it. If we want to calculate what's called the correlation coefficient, okay, and we're going to talk more about that in a bit, but if we want the calculator to do it, because we are not going to do it by hand, okay, never, but the calculator will do it. If we want it to do it, we have to tell the calculator. It's not an automatic. So we have to find it in our calculator. So what it says is from the home screen, press the second key and then press the catalog key. So second key and then catalog is down here at 0. Okay, so second 0. And then we need to go all the way down to diagnostic. Well, there's a lot. It's alphabetical order, all these things. I don't know what hardly any of them are, but they're things that you can do in your calculator or add in. So the fast way to get to the D's for diagnostic is to press the just a sec, x to the negative 1. We want the alpha key, okay? That means it's going to give us anything that green here, so D. Oh, that didn't work, sorry. Alpha key, D. Okay, so alpha x to the negative 1 will give us the D. It means it will go to the D's in the diagnostic. It's just a fast way. You can cursor down, up, or whatever. And then from there, keep going. It's in alphabetical order to diagnostic on. Enter on that. Okay, you should see it in your calculate screen. And then enter on that. And it'll say done. It will stay in there now until you clear your calculator. So the next test that we have. All right, so to enter the data, we've already done this in the last part. So we go to stat, edit. I probably still have some stuff we were working on last week. So I'm going to go cursor up. I'm going to clear these off. Oops. So clear off your lists. Go back to this one. Okay. And then we want to enter the 10C marks in L1, and then 20- marks in L2. So go back to your list, I guess that was at the top of the page, and just take a few minutes to enter those. I'm going to do the same. Okay, and then you can tell my cursor's on the 34th entry, and so I'm supposed to have 33, which makes sense, because that was on a blank entry. I'm just going to scan, make sure I have 2 digits on all of these, because sometimes on the smart board it doesn't connect, it doesn't read all of it. Yeah, I'm good. Okay. I'll give you another minute or 2 to enter those. Oh, I got to do L2 too. All right. Got those okay. Let me know if we got something different once we do our calculations. Who needs more time in entering? Just raise your hand. Click raise your hand. Okay, I'll wait a little bit longer. Raise your hand if you need more time. Okay, so now we're going to do our actual regression. Okay, now, a couple things. The way that they do it on the calculator is that they do the regression and then they talk about graphing it. I like to do it the other way around. So I like to graph this data first before I do the regression. So, graphing, go to y equals, okay? Remember we did some plotting last week. I'm going to go and turn those off right now for sure. And then make sure that there's no y equals anything in there, okay? Then I'm actually going to go to look at plot 1. We'll turn it back on, but with some different properties. So second y equals, and enter on plot 1. And remember, I guess the last time I did this, I did a histogram. So I'm going to turn this on, but go down to the first, basically the basic normal graphing is graphing those points. dot plot there. Enter on that. And then your X list is L1. That's your 10C marks. And Y list is L2. Okay? So, we can quit out of that. You can tell that if you go to Y equals, your plot 1 is on. So if we decided to do a dot plot, it's ready to go. Thing is, we need to make sure the window is correct. So go to your window, and those values aren't going to make sense for this. So remember, our values are, they're marks, right? So you can go from the lowest to the highest, or because they're marks, you could go from 0 to 100, right? That's what I think what I'm going to do. So 0 to 100, and if you go up by 10s or by 1s, doesn't really matter. And then for Y, 0 to 100. Okay, and never change anything about X resolution or delta X. Some of you won't even see those bottom things. Okay, now press graph. And you should see all of those points, right? So for each row in those lists, the 10C is the horizontal X value, and the 20-1 is the Y value of each of those points. So it does look like it's a positive correlation, because as the marks get higher in 10C, the marks in 20-1 are higher. Kind of makes sense, right? It's not a really strong correlation. It's okay, right? Certainly if you can tell what the trend is, whether it's positive or negative, then there is some correlation, right? It's just not super strong. Now we want to do a line of best fit. So that's where, so I've done the graphing part, which actually is listed on the right-hand side of your page, how to get it to graph, but partially anyway. We haven't done the line of best fit. So now you go to the left-hand side of your page and go stat and calculate. Same place that we did our one variable stats. Okay, there's a question here to the set. In your calc, you want to go down to number 4, lin reg. So that stands for linear regression. Regression is basically the calculator will measure the distances between the points, okay, and the average of the points, and then calculate the best line that basically goes through as many points as possible, evenly between them. Okay, so it does a calculation. So we're going to, and you can tell it says AX plus B, that's slope y-intercept form, right? If you were to make a mistake and go to 8, then it's going to show it in a different form. So we never use 8. We always use slope y-intercept form, which is linear regression. Okay, now, in my calculator, it's a newer version, so it prompts me. And it says X list L2, Y list L2. It just keeps whatever was in there. Well, that doesn't make sense. I want to do X list is L1, so second 1, and Y list is L2. Frequency I leave, and store regression equation. So that is nice to do, because that means it will graph your line of best fit, which is really what we want it to do. So where do we want to store it? Well, remember, in order to graph a line, we put it into Y equals, and usually into the first one, Y1 equals. Well, that's what we want to tell the calculator to do, store it in Y1. Well, how do we get Y1? Y1 is from bars, which is variables, that's what that means. Okay, then you see Y variables as the second. Okay, so arrow to the right, and a linear regression is a function. All of these regressions are functions. You'll never use number 2, 3, and 4. So just enter in function, and there's your Y1. Okay, if you have an older calculator, then you're going to do the same, and you will see this on your screen. Okay. So then you want to enter L1, with a comma, L2, comma, and then the Y1. So if you have an older version of the calculator, you actually see that flash up on the newer versions once I press calculate. But older versions, you have to, they don't prompt you for those particular lists and values. Okay, so then calculate, so you can see it flash there, and then it gives you, okay? All right, to do Y1, okay, you do bars, Y bars, okay, just let me clear it again. So stat, calc, new regression. Okay, so to store it, you go bars, cursor to the right to Y bars, enter, enter. And then enter again. Okay, so what's your equation? It says the form is y equals ax plus b, where a is 1.017, etc. B is negative 14.05. So if you were asked the equation, you'd probably be told to round, maybe to 2 decimal places. That would be your equation. That's not the exact equation because you rounded it, but that's as close as you can get. Then there's some r squared, r values. Okay, so those r is your correlation coefficient, and it talks about it. So check. So I'm going to just graph it right now, and then I can tell if I'm off. I'll come back to this in a sec. Yeah, that's pretty good to me. So I think this is just a similar screen, not the actual screen for that one. Okay, so let me go back. Unfortunately, it deletes like your, maybe let's do this. No, it deletes your regression. So if you go to graph it, you actually have to do the whole thing again. Although, actually, I shouldn't say that. What you can do, I'll show you in a sec. To get the equation, you can go back to y equals, but to get those r values, you have to actually do it again. It doesn't save them. Okay. Right, so our r value here, so the equation of your line of best fit is values rounded to the nearest 100. That's what we're going to put in here. So y equals 1.02 x minus 14.06. And the correlation coefficient rounded to the nearest 100. So here I'm going to put r, and I'm also going to put r squared. Okay. Now r, I'm going to put 0.79092667. If I actually take, because I can't go back and select that, but if I go 0.7909 267 and square it. Okay, this is at 0.7909 267 and square it. Okay, I get basically what the r squared value is. So r squared is just the r squared. That makes sense. All right, and basically r can be positive or negative. If r is negative, then it's got a negative correlation. right? It's got a negative slope. If R is positive, then it's got a positive slope. So oftentimes we actually look at R squared because we don't really care if it's a positive or negative slope, right? When we're looking at R. So the closer the value that R is to 1 or negative 1, the better fit it is for the points, or the closer the points are to the line. So an R value of 1, or R squared of 1, means the points are all exactly on that line. Okay? Nothing is away from it. Anything that's less than 1 means there might be some points that are not on the line. Okay? So that's what's listed in the next part here. Correlation coefficient R satisfies this inequality. If R is equal to 1, then it's a perfect direct correlation because all the data values lie on the line of best fit, and the line of best fit has a positive slope. If R is negative 1, perfect inverse correlation, all the data values lie on the line, but it's a negative slope. Okay? The closer the absolute value of R is to 1, the stronger the correlation is between the two variables, and the closer the points will be to the line of best fit. If R is close to 0, there's very little correlation. Okay? So sometimes we might ask you for R, sometimes R squared, but they both show up in most of these regressions. Okay? Someone asked about A plus BX. No, I said we don't use number 8, A plus BX. It's a different form. Okay? We use slope y-intercept form. And ln reg is logarithmic, so we definitely don't do that. We will next year, perhaps, but not now. Okay, so we know how to graph, so we've done that. Okay, so your regression equation can be used to predict Math 20-1 marks for given Math 10C marks. Use your regression equation to predict the Math 20-1 mark if a student received the following marks in Math 10C. Go to your graph. It has your equation in there. We want it to be as exact as possible. If we use the rounded equation, it's not going to be as exact. If we use our graph, it'll be as close as possible. So remember, 10C is your horizontal. So if you go trace, first thing that it traces on, if you look at the top left, is the plots. So if you go left and right, it's just going through all the plots that you listed. Cursor down, and that will get you onto Y, your function. And notice how it shows the equation, but with a whole bunch of decimal places. That you can see blah, 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 x plus negative blah, blah, blah. Okay, so that's the equation without rounding. So we want to find 70, so just punch in 70 for x, enter, and it will go to the line of best fit, 57. Okay, 60, so we're in trace, 60, 47. Okay, basically it's looks like it's about 13% lower. Okay, so another way to, if you look at y equals, it will also show you the equation. So if all you needed was the regression equation and you cleared it for some reason, and you didn't need the R squareds, you could just go back to y equals. Okay? So that's where we're at. So the exercises are for you to do. The first one is basically given there and then actually plot it by hand. And then determine the equation using technology. So enter it in your calculator and then graph it. And then answer some questions on it. And then question 2 is graphing calculator. Question 3 is by hand to graph it, but then you need the correlation coefficient, so using your calculator. And then some just a variety of questions there. Okay, so that's really the last lesson on statistics, and then we'll start probability tomorrow. Okay.